lecture for just the acceleration calculations for the runners 40-yard dash. And I'm going to do a real quick review since the smartboard stopped working here. We have our distance and times that over here on the left-hand side that you see. And so at the 0-yard line, there was 0 time, 5-yard line was 1.19, and so forth. And you have to show the formula, the calculation answer, and units for average velocity, instantaneous velocity, and acceleration. And we already did instantaneous velocity. And the formula for that, as you saw here, was change in distance over change in time. And so we did use these little delta, these triangles here to signify change in distance. But the way you did it in a formula was to get the change in distance, you take the final distance you went minus the initial distance you went, and then divide that by the final time you went divided by the initial time. And so that's what we did. And I'm going to keep all of these answers that we got in the last lecture here. I got to keep these answers handy because we're going to use these velocities at the 5-yard line, the velocity at the 10-yard line, and the velocity at the 15-yard line to do accelerations. Now the formula for acceleration is right down here. It's really similar to instantaneous velocity. Acceleration is the change in velocity. It's how fast are you speeding up. So we're going to take the change in velocity over the change in time. Feel free to stop this video at any time if you need to get the notes. And so I'm going to take delta V, which means change in velocity. That little triangle means change in, divided by change in time, so delta T. And to write that out the long way, change in velocity is the same thing as the final velocity minus the initial velocity. I'm then going to divide that by the final time minus the initial time. If you notice, the bottom ones up here, the final time minus the initial time, was the same as up here in velocity. So we had final time minus initial time. So we're going to use these same numbers in the equations down here as we used for velocity. So acceleration and velocity are going to be the same as far as the bottom numbers. Now, instead of writing all that out, I'm just going to make it a shortcut, and I'm going to say A for acceleration, V sub F. When I say sub, that means subscript. So that means final velocity, that V sub F right there, minus V sub I, which means subscript I means initial velocity or beginning velocity, divided by final time minus initial time. So let's figure out how we're going to do all these formulas here. And I'm going to erase this. So let me stop it here for a second. All right, so I'm going to do the first yard line here is the acceleration between the 0 and the 5. So that's where I'll put the A from the 0 up to the 5. That's where I got this right here. And the formula for acceleration is final velocity minus initial velocity divided by final time minus initial time. Well, let's show you where I got this. Well, the final velocity is going to be the velocity at the 5-yard line. See that little 5 right there? So I got to come back up here at the 5-yard line. So this one right here, the velocity at the 5-yard line was 4.2 yards per second. So I'm going to take that 4.2 and I'm going to put it in that formula where it said BF, 4.2 yards per second. Well, my initial velocity at the 0-yard line was 0. I wasn't going anywhere. So I'm just going to put a 0 right there. And now I have to do final time minus initial time. Well, remember me just saying that the final time is going to be the same thing as it was up there with the velocity equations? So let's take a gander up here. In your chart, the final time was 1.19. The initial time was 0. And if you notice in your velocity equations, there it is right there, 1.19 minus 0. So I'm going to take that same thing and put it down here. Okay. 1.19 minus 0. And then you divide those two numbers and you get 3.53. Well, the top part of the velocity was yards per second. The bottom part is seconds. This is all seconds here. So it's going to be yards per second per second. And what that means is the runner was speeding up 3.53 yards per second every second. So they went 3.53 yards per second faster every second. Now, we also write this a little bit simpler. We usually put 3.53 yards per second squared is how that would be stated. Okay? Now we have to do the acceleration between the 5 and the 10. So we're going to do another one like this. So I'm just going to do the same formula again. Acceleration between the 5 up to the 10 equals final velocity minus initial velocity over final time minus initial time. So let's see what we're going to put in for the final velocity this time. Well, the final velocity is going to be the velocity at the 10-yard line. The initial velocity is going to be the velocity at the 5-yard line. So we're going to come back up here and look what those velocities were. Well, the velocity at the 10 was 7.69. 7.69. So I'm going to put that in down here in this formula. I'm going to put 7.69 minus the velocity at the 5-yard line. Well, that was right up here, the 4.2. And then my times were going to be my time at the 10 minus my time at the 5. Okay, so you're always looking at the 10 and the 5 here. So you come back up here, the time at the 10-yard line was 1.84 minus 1.19. So 1.84 minus 1.19. And once again, those numbers are exactly the same as the ones we used right here in the velocity equations. So 1.84 minus 1.89. I'm going to divide the top and the bottom, and we're going to get that answer. That answer ends up being 5.37 yards per second squared. And then lastly but not leastly, we have to do the acceleration between the 0 and the 15. I'm sorry, the 10 and the 15. Now you're going to go all the way up to 40. Okay, so you just keep doing, I'm just doing some example problems here. So I'm going to take my acceleration between the 10 up to the 15. So again, I'm going to write down my formula every yard line. And I'm going to put my time at the final time, that's initial time. Well, I need my velocity at the 15-yard line. So I'm going to come back up here to the green. My velocity at the 15-yard line was only 5.68. So I'm going to bring that down. 5.68. My velocity at the 10 was this 7.69 we got from above there. I'm going to go back up to the velocity equations and steal those times at the 15 and the 10. You notice the 15 was 2.72 and 1.84. There it is right there where I put it in, 2.72 and 2.84. So I'm going to put those down here, 2.72 minus 1.84. And now I'm going to divide those numbers. And when I divide those numbers, oh, I get something weird here. I get a negative 2.28 yards per second squared. Well, let's discuss what that means real quick. If your acceleration is negative, that means you're slowing down. And if you look at it, it does make sense. Let's look at these velocities up here. The velocity at the 10 was 7.69. But then at the 15, I slowed down to 5.68. So therefore, when I did my acceleration, my calculations came out to a negative 2.28. So it means you're actually slowing down on that one. Okay? So once again, you'll need to have average speed, instantaneous speed, and accelerations for each yard line for one runner. So you're going to have 24 different problems. You need to have the formulas like this. You need to have the substitutions like this. You need to have the answer and the units for every yard line. Get points for each one of those. Hope this helps. Have a great day.